All right, so I'm going to do some more proofs just as a little review. The kind of the most basic proof that we have is one where I'm just trying to prove two triangles congruent. And as I always like to remind students that we know that the first um, statement is always going to be the given. The reason is going to be the given, and the statement's going to be, well, whatever I'm told right there. So in this case, I'm told AB is parallel to ED, and I've got it marked that way already, and also that AC is congruent to CD, which is also marked out already. And if it's not marked, I should mark it because it'll make things easier for me for figuring this out. And I know my last line is always going to be what I'm trying to prove. I don't know exactly how much space I'm going to need here, but I'm just pointing out, I know this is going to be the last line. And actually, I do know how much space I'm going to need, but I just want to point out that's always going to be the last line. I don't know what the reason is yet, but when I get there, I'll know. Okay, so we're trying to prove these congruent. I've got one thing marked. I need at least two more to do something like a side angle side or an angle side angle or side 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 or whatever it happens to be. So one thing I see immediately is I can mark those right there. So I know that angle BCA, which once again, BCA is this angle here, is congruent to angle DCE, which is that right there. And the reason is, oops, I'm putting it in the wrong place. Angle BCA is congruent to angle DCE, and the reason is vertical angles, or vertical angles are congruent. Okay, vertical angles are congruent. I just need one more thing. I don't know anything about those sides. This does not mean they are congruent. It means they're parallel, but they are parallel, which tells me something. And at this point, I actually kind of have a choice. I'm going to, because I've got two sets of corresponding or alternate interior angles. So I'm just going to mark the one that I see is the most free there. So I'm going to say that angle B is congruent to angle E. And I can use one letter because there's no confusing about which angle B and angle E I'm talking about. And the reason there is alternate interior angles are congruent, and that's in a parallel line. And then I actually have enough stuff marked out. I've got an angle, I've got an angle, I've got a side, I've got an angle and an angle side. And the only question is this angle side angle or angle angle side? So which is it? That's right, it's angle angle side, because the side is not between the two angles. If it was right there, it would be angle side angle. And if I had actually marked these two angles, it would be angle side angle. But the reason this is, we've already got our reason triangle ABC is congruent to DEC is because of angle angle side. So that's a basic proof. Getting a little more complicated. This is a little one of the ones we did in class. And I'm going to actually have a little sidebar here. I'm trying to prove that if I'm given this rectangle here, that AC, which is this diagonal, which is not drawn in, is congruent to BD. Okay, and that looks like it's congruent. I've got a little hint there. And this is hard for people to visualize sometimes. So I say it's actually, we're going to compare triangles. We're going to try to get triangles congruent, so then we can prove, hey, the other parts that aren't marked, we can prove congruent by CP/CTC, or corresponding parts of congruent triangles are congruent. But I need a triangle here compared to a triangle here, because I want to be able to prove that these two things are congruent. So I'm going to kind of mentally separate these out so you can see what's going on here, because sometimes this is visually hard for people to see. I'm going to separate these two triangles out. These are actually overlapping in the picture. But so this is the left triangle here, no, the right triangle here, over here, the right side. And then this one right here is there. Now, what's easy for most people to see right away is, well, I got right angles here, which is actually the first hint I already gave you. And actually, let's make sure we get our given in there. ABCD is a rectangle. I'm going to abbreviate. That's given. And they are congruent because they're both right angles. And the reason we know that is, well, I know what a rectangle is. It's the definition of a rectangle. A rectangle has 4 right angles. That is the definition. Okay. Oops. If you had said something like a rectangle has 4 right angles, that would be correct too, but definition of a rectangle is kind of the easiest thing to say. Okay, and I'm also going to put those marks here so you can see the same triangles. It's just a little easier to visualize because I'm trying to show that AC is congruent to BD. All right, what else do we know is congruent? Well, our old friend, a common side. This is where I separated out. This side is in the triangle on the right and the triangle on the left. It is in both of them, okay? And the reason that we typically say for that is same segment, or if you're being fancy, you can say reflexive property. Okay, I need one more thing. I need another angle or another side. I don't know anything about those angles. I don't know anything about this side. In fact, that's what I'm trying to prove congruent. What I do know is this is congruent to this because we just did a proof earlier in the day that parallelograms have opposite sides congruent. So I'm going to mark it here too. So I'm going to say AD is congruent to BC because parallelograms have opposite sides congruent. And then I'm going to say a rectangle is and I'm just going to make a little symbol, parallelogram, running out of space. Okay, pretty small, but the basic idea is I know the rectangle is a parallelogram. We know that parallelograms have opposite sides congruent, therefore it's that. Now it's pretty easy for me to look at these two. It's a little harder to look at this one. This is why I separated them out and say, oh, those are congruent because of side angle side. So I know triangle ADC is congruent to triangle BCD. Make sure you get that order right. Right angles have to match up. And then finally, we say, oh, now that I know the triangles are congruent, I know AD is congruent to BD because of corresponding parts of congruent triangles are congruent. And once again, what all that says is once I know the triangles are congruent, which I just proved, I know the other unmarked matching parts are congruent. I know those two are congruent. I know that A and B are congruent. I know that C and that D are congruent. All right, I'm going to squeeze one more in. I may go 10 minutes here, which is a little long for me, but I'm going to do one more. Okay, I'm going to show you this one right here. Okay, this is a parallelogram. We're trying to prove that US bisects RT. So we're trying to show that this thing chops this in half. And first of all, once again, RSTU, easy points, is a parallelogram. I'm going to abbreviate, and the reason's given. Okay, and then I gave you a hint. I said, oh, RUS, which is this angle, is congruent to TSU, which is this angle, because of alternate interior angles on parallel lines, because it's a parallelogram. We know that's true. And then these lines are parallel too. So I know that this angle is congruent to this angle. This was given to me. And this is one of these things where if you've never done a proof like this before, you may be kind of searching around. Which triangles am I trying to prove congruent? Which triangles can I prove congruent? What angles can I figure out? Sides can I figure out? But I've done a lot of these, so I kind of know some of the tricks. Okay, I got 2 angles marked. I need one more thing to mark, and I can use the same trick we used in the last one. I can say, oh, well, this side here, which has got the parallel line on it, I'm going to go ahead and make a really big mark on there. So I've got 2 marks. I've got parallel marks and I got congruent marks. I know that RU is congruent to ST because opposite sides of parallel lines, of parallelograms, are congruent. Kind of the same rule we used last time. I'm a little off the screen there. Okay, almost done here. Now, they're crossing. Well, I'm trying to prove US bisects RT. So RT is this. I need to prove that this thing's cut in half. Well, I actually know that RT, or this thing here, which doesn't have a letter, and I gave you a hint down here. I need to add a letter in here. I can call it anything, but I call it X. I now know that RX is congruent to XT because of, oh, I know it. I'm getting ahead of myself. I know it because of CPCTC, but I've left one step out. I didn't say that these two triangles were congruent yet. Okay, so triangle RXU is going to be TXS. And the reason is angle, side angle. Then I know this right here has to be congruent to that now because the triangle's congruent. I know that the other parts are congruent by CPCTC. And now that I know these two things are congruent, I'm like, oh, well, those two things are congruent. The definition of a bisector is it cuts through at, into two equal parts. Technically, it's at a midpoint, but we're going for brevity here. So I'm going to say I could have already filled this one in. US bisects RT, because we've just shown that RX and XT are congruent, and we can see that they intersect there. Okay,